Welcome to in the integration video series. We're on to video 4 now, where we're exploring definite integrals. Unlike indefinite integrals, where we could only get an expression for the integral term, here we're able to sub some numbers in and get a definite final number answer for our area under the curve. Let's have a look at one key example, and that should illustrate most of this. So here we go. To find the definite integral between x equals 1 and x equals 3 of this expression here, 4x squared plus 6x dx, we have to integrate first. But we're going to put square brackets around it first, and for a very special reason, because we're going to sub in 3 and 1 into it in a special way in a moment. So we'll integrate 4x squared. So when we integrate, we add 1 to the power and then divide by the new power. So 4x squared, that squared will become a 3, and we'll end up with 4x cubed over 3, because we divide by the new power. And with 6x, we add 1 to the power, which becomes a 2, and divide by that new power. So we'll get 6x squared over 2. And we have square brackets there. We're going to put a 3 up the top and a 1 down the bottom. There are our x values that we're going to sub in later. Now you notice we don't have a plus c at the end because we don't need it. We've got specific x values to plug in. So we'll just simplify this second term a little bit further, because with 6 over 2 will become 3 here. 4x cubed over 3. 2 goes into 6 3 times. And we'll have our 3 and our 1 there. So we've integrated, and now we're going to sub 3 in and sub 1 in. Now the pattern we're going to use here, we're going to do a substitute of the top number, in this case 3, and we're going to do a minus the substitute of the bottom number. Now I'm going to put a bracket around that little guide there, because it's really important in these questions to be careful with the subtraction of the second section. So let's have a look here. Now, so when we substitute 3 into wherever there's an x in this expression, we've got 4 lots of 3 cubed over 3 plus 3 lots of 3 squared minus, and I'm going to put a big bracket there, so I'm really careful with my substitution here and my subtraction of the second section. I'm going to put a 1 wherever the x is in our expression here. So 4 lots of 1 cubed over 3 plus, inside the bracket there, 3 lots of 1 squared. Okay, we've subbed in our 3 in this first section and our 1 wherever there's an x in the second section, and we're going to be really careful with the minusing. Okay, 3 cubed is 27, so 4 lots of 27 is 108 over 3. 3 squared is 9, so we've got plus 27 there. Now minus, let's keep our bracket for now. 1 cubed is 1, so we've got 4 over 3 for that first bit. 1 squared is just 1, so we've got plus 3 there. Final answer, when we either type all that into your calculator or whatever else, is 58, and we get 58 and 2/3, and we're going to write square units, because we're finding, remember, the area under a curve in the end. These actually should be just maybe a little bit approximate. Actually, they're definite integrals, so we should just leave them as equal signs. So that's our final answer there. Now, just to recap, we integrated to get this first section here. We integrated, and then we subbed in 3 wherever there's an x, minus 1 wherever there's an x. But we've got one key thing for the whole success here is to keep this second section separate and then subtract carefully at the end. Alright, now that's only one example, but I think that illustrates pretty much everything you need to know about definite integrals. There's some variations in the questions you get, but that's the pattern. We integrate, then we sub the top number in and subtract the substitution of the bottom number. Hope that helps. Enjoy.